the team. Yeah, we're recording. Okay.
Hey.
We're here to tell you about a little bit about Kaleidoscope, as well as how we use it in our office and how you can kind of use it in different ways in your design process as well. And we should hopefully have a lot of time for questions and discussion at the end. But definitely feel free to put your questions in the chat as we go. And if it's an easy answer, one of us might answer it. Otherwise, we'll wait till the end to get to them. Thanks. So we are an architecture firm that happens to do a lot of research within it. It's part of the ethos of Payette. And we make up a diverse team in the office. We're just some of the team that works on Kaleidoscope. I'm a building scientist, but Yoko and Olivia and Lizzie are all designers, and we have architects on the team, and we have, we've gotten our marketing team involved, as well as we've got somebody who helps with the coding on that side. So we originally came up with Kaleidoscope, and this kind of as a research process in 2019. It's been a really ongoing process. And originally, in building science, I do a lot of the analysis in our office. And we kept asking this question, besides just aesthetics, if we're looking at our envelopes and our facades, can we start to look at them for embodied carbon? You can go to the next slide, Lizzie. And we were doing these one-off studies, using Tally, and we needed a Revit model, and it was taking a long time. So often by the time, because we were also learning the process of how to do an LCA ourselves. And so often once we finally found the answer, the design team had kind of moved on and already showed the renders to the clients. And we realized since we were doing the same questions a lot, we wanted to develop, a menu was kind of how we originally started this idea of all of the variety of different facades that we use. And that kind of evolved that, it was just a really complicated presentation. We presented about it, and it was really a lot of graphs that we decided to turn it into an interactive tool because we thought it'd be a way better way to present all the data that we were looking at.
There are many tools that currently run LCA studies. However, based on our firm's typical design process, we found that they're more suitable for when more detail are known about the design or required more detailed 3D models. The concept of Kaleidoscope is to present apples to apples building assemblies to help designer make more informed early decisions. Kaleidoscope is meant to bring embodied carbon to the table when the first conversation about materiality are happening in a quick and accessible way. Our tool is, hold on, could you go back? Sorry. Our tool is not meant to replace, but supplement whole building LCA in a phase, even before there is a 3D model for a project. Next slide, please. The graph on the left shows the general breakdown for a typical office building. Envelope and interior finishes account for about 20% and 14% of the whole building, respectively. The graph on the right is an example from one of our healthcare interior project and shows where the embodied carbon hotspot are in interior project. All of these areas are where architects have direct influence on aesthetic choices that have embodied carbon consequences. And these are the areas Kaleidoscope targets. Next slide, please. This is what Kaleidoscope landing page looks like. To target those hotspots, we have 4 types of assemblies. They are envelopes, floorings, ceilings, and partitions that can all be compared in an apples to apples way. We have a demonstration on how to use this tool later on.
Yeah, so we actually started with the envelopes first, and over time, about once a year, we've added the different systems. And so we're actively actually still working on Kaleidoscope and adding new systems to it. And so for the envelopes, what's unique about them is that, they have an operational carbon impact. So we wanted to make sure that to make them apples to apples, they were the same R value. So in addition to doing all of our Tally models and LCA models and Revit, we also ran parametric therm models to make sure that all of our systems were actually the same and adjusted kind of the insulation thickness to account for that. And so at the time, they're all the same R value of 15.625, which was the code in 2019. But you could still use this, even if you have a stricter R value that you're looking at, you can still their comparison, the values are still going to be the same. You just might need to account for a little extra insulation. Your overall values might be a little higher. So then we took those kind of calibrated models and then we turned them into a tool. And so, and also to make them apples to apples, we made sure that all of our systems had the same system boundary when we were modeling them within each system. So the envelopes had a system boundary, the flooring, the ceilings, and the partitions, they were all modeled with the same volume and area. And then we are presenting the data in a per square foot.
So this is just a quick snapshot, kind of the general overview. This is the interface of the tool. And just to start off with, we're going to kind of go through the different lenses that we've included. So at the top of the Kaleidoscope tool, you can see there's different chart types, different ways to view the data, and a little bit of different kind of lifespans. So I'll kind of talk through those really quickly. So at the top, we refer to these as the different lenses of the tool. We all know that the time value of embodied carbon is now, which is why we've included this initial carbon lens, which only includes module A. So it allows you to get a quick snapshot of that initial carbon impact of the assemblies. And then we've also included the 60-year lenses with and without module D, and I'll get into that in a little bit. So with, you can see here, you've got all of the different modules. We have the option to include module D in the data or exclude module D. And the reason why we choose to exclude it with one of these lenses is because your recyclability is currently unknown. You know, you don't know 60 years into the future exactly what the recycling process is going to look like. And, you know, it's an estimate basically to account for those credits. And it's also optional in some certifications. So that's why, you know, we don't think it should be exactly what defines your selection, but we have the option to view the data with that included. Another lens that we have looks at all of the different life cycle impacts combined together and kind of weights them. So this is a good way to kind of see things beyond the global warming potential. And then we have a lens for biogenic carbon as well, which accounts for the carbon sequestration when you're using FSC or sustainably forested wood or biogenic products.
And on our interior assemblies, we have also included an additional lens for material health impacts. And this is to incorporate our Payette's material health policy into it. And so these ranks it based on colors of, like, if it's darker green, it means that typically will meet our material policy, all the way from like red means it just like does not meet it. And then yellow means you might need to have some special requests. So there's some little question mark there that gives you more information. And then to the next slide. So our policy is actually based on the 6 classes of chemicals. So if this is similar to your office or you're curious about this, you can certainly use this lens too. But we're restricting the use of highly fluorinated chemicals, antimicrobials, flame retardants, and vinyl. And so this is reflected in like those kind of what's typically done in each of those assemblies. And then you can also find more information about it. There's this pop-up that you'll see in the demo where to find this that Lizzie's going to show you in a little bit. And there's a little bit more information about that material health policy there as well.
All right, so next up, we wanted to do a quick demo of Kaleidoscope and its interface. You'll find it by navigating to the Research tab on the Payette website. And then if you scroll down the page a bit, you'll find a list and description of some of the tools that have been developed in the office over the last few years. You can either click on Kaleidoscope through there or just go to payette.com/Kaleidoscope. So this is the landing page. And this button here starts the tour, or you can navigate directly to one of the assembly types listed here. If you scroll down, you'll find descriptions of how the tool was developed, how to use the tool, and the methodology, as well as an outline of the system boundaries that Melanie referenced before. On the side over here, you'll find some additional resources that could be useful for your embodied carbon research, such as the Tally website, the CLF website, of course, and global environmental reports. We've also won a few awards, including the 2021 AIA Innovation Award and 2022 Architect Magazine R&D Awards, which you can read a bit more about here. There are other articles that have been written about Kaleidoscope, and here you'll find all of the blog posts that we've written on our own website that explain more of our process and the updates as they were released. So scrolling back up to the top, let's take a look at some of the assemblies. We can start with envelopes right here. At the very top, you'll still be able to switch between the different tabs of the for the different assemblies. So you'll see that the data and categories start to change. Just below that, you can still start the tour even after you get to the assembly page. And there are two different ways of sharing the data that you've collected from there as well. Just below that, we have all of the lenses that Melanie and Olivia just explained. For instance, here we have the global warming potential first up, and then you can also switch to see all of the impacts, the embodied carbon impact broken down per life cycle stage, and per material according to the system boundary diagram, which will be illustrated on the side. Oh, there we go. You'll also be able to switch between the lifespan and then decide whether or not you want to include biogenic carbon. There's also a little question mark next to each of these lenses in case you want some more explanation of what exactly you'll be looking at. In the middle here is the overall bar graph showing the relevant data for the chart type. Here we have the overall GWP, where the bars are grouped and colored according to the overall material or structural type. And then if you hover over it, you'll get a description of the assembly, an axon, and a precise GWP value for that portion of the bar. On the right-hand side here is the legend, listing all of the assembly types that are available. There are little checkboxes if you want to include or exclude certain options. So you're looking at just what you're most interested in. And you can also use these two buttons right here to clear them all or bring them all back. You can also click on any of these, on the names in the legend, and you'll find this pop-up window right here. This will show you a bit more information about the assembly and all of the included material. And we'll see it broken down in a section or plan diagram. This also corresponds to the, so you can see how each material, of course, impacts the total GWP of the assembly in the pie chart. In the drop-down menu, you can adjust this pie chart to show its impact relative to the lifespan lens. And below, you can find more information about the assumptions we made when building and analyzing the different assemblies. And then at the very bottom of the page, you'll find a calculator where you can start to build some of the assemblies yourself and start to compare them right here on the web page. You can change the lifespan that you're looking at it with and then start to pick what material type. Within each option, you can start to add rows, so you can have two different materials listed there. And you can also keep adding more options so that you can have as many different assembly types as you like. And then as you start to type in the square footage, it'll automatically calculate the embodied carbon.
So one of the first assembly we added was envelope. The envelope system are organized by the general construction type, such as masonry veneer, face sealed, curtain wall, and rain screens. The data is represented on the per square foot basis, allowing designer a simple metric to multiply by their facade areas. So we're going to do a design study together. Say we're considering 4 different designs, and we want to evaluate them for embodied carbon. I invite you to type in the chat which options do you think would have the lowest produced embodied carbon. Next slide, please. So here we can see the result by square footage from comparing these 4 design concepts on Kaleidoscope. And if you choose to work this into the project concept early, it can inform the design and in a meaningful way. So the answer is option 3. Did you guess it right? Looking more in depth and comparing option 1 and option 3, option 3 achieves 54 reduction in embodied carbon. One big reason why option 3 is the lowest can be illustrated in the material breakdown graph. A granite rain screen system has a significantly lower GWP than the masonry veneer system. You can see that the greatest contribution to GWP is the granite veneer itself. This allows you to propose to switch rain screen system if it doesn't impact the aesthetic that the client desire. The intent isn't to say that as a designer, we should never use certain material. Instead, it's to educate so that we can be strategic about when and where we use the high impact material and make more informed, mindful material decisions. Reflecting on options and result using calculator, we realize it is important to be mindful and strategic about the use of high embodied carbon system. And lesson learned is less material, granite veneer, same aesthetic as solid granite.
There's another example of how we've used Kaleidoscope on one of our projects. This is a university lab building at Wesleyan that's currently in construction right now. The next slide. And so one of the big design features of this is it has this really beautiful limestone masonry veneer facade, which is literally just kind of the example that Yoko was talking about. And in this case, we weren't able to switch it to a rain screen, but we were able to, because it was a little too late in the process. This project was being designed when we were in the middle of creating Kaleidoscope. But what we were able to do is actually talk to the design team, and they were able to reduce the thickness. So instead of the standard kind of 4-inch thick masonry, they went down to a 3 inches. And so we were able to reduce the facade embodied carbon in that way, while still keeping a lot of their aesthetics that they had already kind of sold to the client. And so then we did end up doing a whole building LCA for this. And this was one of our early LCA projects. So we only have an 11% global warming potential reduction overall, which was great for something a couple of years ago. But now we're seeing a lot of our projects are getting more in that kind of 30% range. And so, a different way of kind of asking that kind of takeaway is, can we achieve the same aesthetic with a smaller use of material? And so this is something that we're trying to do a lot in our projects, especially, when aesthetics really play into it. So you can think of this as well of like, can your terracotta extrusion be less, be lighter and thinner? Can you use thin brick instead of a masonry veneer? So these are the questions that Kaleidoscope kind of brings up. Another way that we use Kaleidoscope on a project, this is another project that is just wrapping up construction right now. I think actually occupancy just started. This is for Penn State University. We have this really beautiful new lab building there that we have a really large curtain wall on, you can see in this image. And so we actually used Kaleidoscope as a proxy for the curtain wall, looking at using the spandrel option that we can see if we switched it to a timber curtain wall versus aluminum. And so in this case, we actually are using timber curtain wall. And so we're able to kind of illustrate the embodied carbon reduction through Kaleidoscope before putting it into our whole building LCA.
And here's another example. This was a academic research laboratory building, and this client was a developer. They didn't have really, rigorous sustainability goals, but we wanted to see during schematic design how much of a reduction we could get just by kind of swapping some things here and there. And so we were able to use Kaleidoscope kind of between the SD initial and SD alternate schemes when we were looking at cost reductions options to look at different kinds of solid curtain wall panels. And so we were starting with a UHPC panel, and then we wanted to see, okay, we have to go through VE process anyways. What other kinds of envelope assemblies can we use that might have a lower impact? And so after schematic design, when we were looking at Kaleidoscope, we found that zinc was much lower, these zinc panels. And so after schematic design, when we eventually ran the whole building LCA, we saw the benefits of running those initial early studies in Kaleidoscope and comparisons in SD, and ended up with an 8% reduction overall, just from swapping to the zinc panels and some things in the roof as well. And so one really good strategy to reduce embodied carbon is to look for lighter, more flexible systems that don't need as much robust support systems because they will have a lower overall embodied carbon. If you have a heavier material, it's going to need a more robust support system. So these kinds of details and supports really matter. And so swapping over to interiors, if we take a look at kind of the overall hotspots in our typical healthcare interior, you can see mostly they're coming from partitions and floors and a little bit of ceilings. And so these are kind of the 3 areas that we focused on next when we were adding interior assemblies to Kaleidoscope. And so here's a recent project that is now finishing up construction. It's an interior fit out. And this is the baseline design case. In this particular case study, partitions accounted for like half of the embodied carbon of the entire project. And so one thing that we found was really interesting. So this fit out is in a very large building. It's only about 20,000 square feet. The base building is like 300,000 square feet. So it's, it only takes up 6% of the base building square footage. And the lease length of this interior fit out is about 15 years roughly. So if we look at the base building embodied carbon over the 60-year lifespan, and we say, okay, if someone were to fit this space out every 15 years, it would add up to roughly around the same as the cumulative 60-year lifespan of the base building. And so you can see this is the importance of fit outs, that these clearly need to be reduced now. And so switching back to Kaleidoscope, starting with ceilings, we're going to do a couple of deep dives into some of the lessons learned and takeaways that we found when researching ceiling assemblies for the Kaleidoscope tool. One thing that we noticed, at least in the US, we found that grills are really popular in these kinds of aesthetic spaces, and wood grills are really popular as well. And so one thing that we found is that at a certain point, the veneer wood baffles become more economical than like a hardwood. And so this is a situation where you really want to dive into the makeup of the veneer product and ask about the substrate and adhesives. This is a typical veneer wood grill that uses a polyurethane adhesive, and you can see that the polyurethane adhesive makes up about 30% of the system's overall embodied carbon impacts. So some manufacturers, after talking to a few of them, they're now using soy adhesives and particle board instead of MDF. But these are the kinds of details that, Kaleidoscope really allows you to dig into and ask these kinds of questions. So one other thing is, consider the growth phase of wood species. Always use FSC or some sustainably forested wood or biogenic materials, and then consider adhesives for veneer products. And then one other point that we'd like to drive home is that economy is often the most sustainable. If you're looking at Kaleidoscope, you'll see that open ceiling systems have the lowest embodied carbon. So anything like acoustical spray or paint is going to have a lower embodied carbon impact than any sort of added ceiling system. And so going back to that original interiors case study that we mentioned, we had a couple kind of cost reduction exercises that became design opportunities. And we used Kaleidoscope to kind of look at, we kind of did this research in tandem with this project, and we were able to understand the impacts of a metal baffle ceiling over something like a PET acoustical baffle ceiling using the EPDs. And so we used the VE process as an opportunity to kind of research these lower carbon materials. And we found that the recycled plastic PET baffle ceiling was the best option. And so you can see here, just that metal baffle is so high in embodied carbon, and switching to the PET gave us a 71% reduction in our ceilings overall.
So we've also completed a section for flooring assemblies, including different types of stone, ceramic, carpet, wood, and other flooring types. So the data seen for ceiling and flooring results highlighted an important aspect of the life cycle stage for these interior materials, the replacement rate. Because of the physical impact that flooring experiences every day, it has much more wear and tear and has to be replaced even more often too. Some softer flooring types in particular need to be replaced most frequently, such as carpeting. You can see the replacement rates highlighted by the white lines seen here in these dark blue sections. And because of that, we really should consider replacement rates in the context of interior renovations, especially spaces that have high tenant turnover, such as offices, and who would want to create a new look for their spaces more frequently. With that in mind, we can use Kaleidoscope to get a better idea of what materials are easier to replace, especially when looking through the 60-year lens. Of course, we want to use materials for their maximum lifespan if possible, but these charts can start to show us that, for instance, wood is easier to replace or better to use if replacing another material. Resilient flooring types can be replaced relatively easily, but should be used a bit more sparingly, while you should consider carefully whether you want to replace stone or carpet. For those, you may want to choose to keep those materials in a renovation to use them for their maximum lifespan, or choose an alternative material if you have to replace it. Looking at ceilings, we can use a similar mindset when choosing replacement materials. Open ceiling types and most wood types are great to use, although grills with veneer should be used more sparingly. And then lay-in tile, cloud, and hard ceilings have a medium embodied carbon intensity, while metal is by far the most intensive. We can also look for more sustainable alternatives to these materials. For instance, a typical carpet has a high GWP, but we can cut that in half by choosing a low pile carpet with high recycled content and a bio-based backing. We can use tools like EC3 to help find product-specific low carbon options in these kinds of situations. Zooming back out, flooring and ceilings were major sources of embodied carbon, but we found that partitions actually have the highest GWP of the interiors. They accounted for about 43% of the embodied carbon in some of our firm's projects, or sometimes even more. This is especially relevant in renovations and with tenant turnover, again, where the layout changes with the tenant's needs and the partitions may all be moved. So this data is what prompted us to launch partitions as a new section for Kaleidoscope, which we added in April of last year. And in this update, we have 29 different wall assemblies representing various glass, CMU, and metal stud and wood stud partitions. We found that glass partitions have the highest average GWP here. And the biggest contributor to this was the thickness of the glass and the aluminum framing. You can see here in mint green is the glass. And in the buck-glazed partitions, we found that the glass needed to be twice as thick, so it contributed to a much higher GWP for these assemblies. The wood frame glass partitions were greatly improved because of the biogenic carbon of the support systems, so we hope to use more of these moving forward. The second highest average GWP was from the CMU partitions. Although it has an intensive embodied carbon, some small adjustments could improve performance, such as removing the gypsum wallboard entirely and just painting the blocks, or replacing that sheathing with MDF. We also discovered that the grout around the steel reinforcing produces a lot of embodied carbon, and adjusting the spacing of these rods can improve its performance. We also studied partitions with metal studs. The first one on the list at the very top is a typical 16-inch on-center partition with gypsum wallboard and mineral wool. And we had that as our baseline. From there, we explored changing the spacing between the studs and substituting the sheathing and mineral wool for other commonly used or more eco-friendly variations. Sheathing and finish material had the biggest impact on each assembly, with the gypsum wallboard adding the most embodied carbon, but switching to a low carbon gypsum wallboard or to an MDF made improvements. For the insulation, glass wool could help improve the system, or cellulose. Switching to cellulose made the biggest difference. And we could also switch from a 16-inch on-center stud spacing to 24 inches. We also want to point out that one of these assemblies in the middle here doesn't use any insulation at all, which performed much better than most of the partitions we tested, even without specifying any other changes. So this was a good reminder to not specify a sound attenuating partition if it's not necessary in certain parts of your interior fit out. We similarly tested these variations of stud spacing, sheathing, and insulation for wood studs and saw very similar effects. You know, you want to switch to a low carbon gypsum wallboard or MDF, and same with the insulation, switch to glass wool or cellulose. At the very top here, you might notice that the quote unquote worst performing wood stud partition is one that increases the stud spacing from 16-inch to 24 inches, which is contrary to the results from the metal studs where the 24-inch spacing performed much better. Here, that 24-inch spacing actually is better in that it uses less material, but because there are fewer wood studs as you increase the spacing, you get less of the benefits of the biogenic carbon. So things like that are important to keep in mind when you start to look at these results and compare your options.
So limiting the height of the stud gauge really matters. Looking at limiting height when optimizing your stud, but keep in mind they don't make up the largest GWP portion of the partition. Our standard is to use embossed, which is already a better option because it's more efficient. 24-inch off-center may be a better for floor-to-floor heights above 15 feet and 1 inch. We are looking into the tipping points in extreme cases of low and high floor-to-floor height. You'll have a different answer as to what optimal. For some lower floor-to-floor heights, 24-inch may be a better option, but you also want to consider application. Renos may not need things mounted to walls, lab independent, but stud types should also be considered when looking at tall spaces. Next slide. Some proprietary conclusion from the partition R-stud. 16-inch off-center equivalency to a standard was 4-inch stud web and thinner gauges. While this did provide easy savings, we didn't investigate this further to maintain 3 5/8 inch web thickness across all partition studies. Next slide. Now, since we have analyzed so many assembly for both metal and wood stud, we wanted to include some specific recommendation for you to apply to your project. We have an industry best version of the left here, which uses material that greatly improve the carbon impact of the assembly, but are still easy to find that include. And many in the industry already suggest making these swaps when looking at sheathing or insulation. So you want to make sure to use all of these together. For both metal and wood, this means spacing your stud at 16-inch and using glass wool and low carbon gypsum wallboard and using an embossed stud for a metal stud assembly. On the right, we have a reimagined version. How could we use the data and take that industry best version step further? For metal stud, we want to use an embossed stud at 24-inch on center with cellulose and MDF, while reimagined wood stud should use 16-inch spacing, also with cellulose and MDF. As you may have noticed, both of these reimagined assembly utilize the wood-based product we studied. In particular, the reimagined wood stud performed the best of all of the assembly and that we studied. So of course, we would hope to recommend that we start to use this assembly whenever possible. Next slide. And additionally, can we redesign our standard wall detail and materials? Next. We touched base on how to use assembly calculator during demo, but here are the comparison of 3 different metal stud wall type. Option one as embossed 16-inch off-center, option 2 as industry best, and option 3 as reimagined. For these three calculation, we set each partition linear feet to 1,000. Comparing option 1 and option 2 reduces 33% of embodied carbon than option 1. And comparing option 1 and option 3 reduces 189% of embodied carbon, which is a lot.
And so going back to our interior case study of the Kempner project, just to describe a little bit about what our baseline was. So we were looking at 16-inch studs on center, mineral wool insulation, which is sort of our Payette standard interior insulation, standard 5/8-inch gypsum wallboard and paint. And again, partitions made up around half the embodied carbon of the interior. So this was a big hot spot that we were trying to reduce. And so we were doing this partitions research for Kaleidoscope kind of at the same time that this project was being designed. And so it caused us to kind of start to question our typical standard details that our firm uses for partitions. So we started asking these questions like, does stud spacing matter, that Yoko and Lizzie just touched on? What's the impact of limiting heights and the gauge size on embodied carbon? Is there a tipping point? Do we need to use embossed or standard studs? And then it caused us to start looking at other insulation and gypsum alternatives as well. Go to the next slide. And so what we were able to get from kind of doing these quick swaps, these quick material swaps, was a 20% reduction. We swapped from mineral wool insulation to a glass wool insulation, and this particular glass wool is basically fiberglass that had a lot of recycled glass content and sand and bio-based binders. For the studs, we swapped to embossed studs, so that basically allowed us to use a lighter gauge for the same structural values. And we swapped from standard 5/8-inch gyp to an ultra lightweight, environmentally preferred 5/8-inch gyp. So it's actually lighter, less material, and they use waste from power plants in their product as well.
So we put all of that together. This is still the Kempner example, and we wanted to see what is all of the different reduction measures that we did. And so the baseline, this includes the whole fit out project. We had a kind of our baseline number, and then we came up with our design number, which was a 39% reduction, combining all of those different strategies that Olivia and Lizzie were talking about for Kempner. And then, because we were doing this at the same time that we were doing the Kaleidoscope research, we had that reimagined, partition assembly that we designed for Kaleidoscope, and we wanted to ask the question, well, how do we redesign this project, and reimagine it? What could we have done to push this even further? Just as a design exercise. We didn't actually implement that. The design is what was been installed, which we're thrilled with 39% reduction, but we just wanted to check what we could do further. And so to get a 55% reduction, we could have switched the gypsum board to MDF. We could have used wood studs, as well as our ceilings. We discovered if we did a 1/2-inch soffit instead of the standard 5/8, that would get us an additional reduction. And then we switched to a even lower embodied carbon carpet that we found an EPD for that we didn't actually use, but it turns out it was like a carbon negative advertised product. And so with these things, we could have gotten to a 55% reduction. So now we've learned these lessons that we can hopefully apply them to our next project. And so, as Olivia was saying, the importance of interior fit outs is way more than we were expecting, especially on this project that was only a small 6% of the whole base building. And so this is kind of our next question that we are exploring in our office and for our research is, how do we actually start to get to these carbon negative design options, and how do we actually implement them on a project so we can achieve that carbon neutrality that we need to get to. And so coming soon, we're also actively working on adding wall finishes to Kaleidoscope. It is projected to be published in April. And we also have a separate kind of parallel team who is looking at reuse, and we're talking with them to incorporate this potentially into Kaleidoscope. So we are curious to hear your guys' thoughts if you think these would be useful as well. And so I think we have 15 minutes left. We answered some of the questions, but I know that there's more questions. We also kind of want to pose a question like, how do you incorporate embodied carbon decisions in your design process? Hopefully some of the ways that we've done it, you can start to incorporate. If you have even better ways, we definitely would love to know. We're always constantly trying to improve everything. So thank you. And we'll jump into questions and discussion. I see there's definitely been some questions that we haven't answered. Let's see. There's a question about the 15-year fit out. Okay, right. Olivia answered that. It's based on that specific project's lease length.
Yes, thank you. You guys have done a wonderful job at answering all the questions in the chat. It's actually the challenge now is finding the ones that you haven't answered.
I
So
think there's a few at the end.
thank you so much. This is so interesting. And I really love that you've gone into the interiors. As maybe some people here on the call know that ASHRAE has this standard out right now, the 240p. It's under review and they're looking for comments. I think they have until March 18th. And it's not only exactly that, the structure and in the envelope, but the interiors they're proposing as well as MEP equipment. So this is wonderful to see what you guys have been doing. Is there anything that we haven't asked or haven't answered that if people want to put that in the chat? Or
I think there was a little bit of questions on the data, so I can just clarify that a little bit. Well, people write more questions. So all of our data is from Tally, so it's industry standard, except for there's a couple specific EPDs in there when Tally didn't have that material, and so it'll say in the little pop up which one of those is a specific EPD if we did use that. And so everything's really industry standard for the North American database that Tally uses for the Gabi database.
Well, that's interesting. Will there be a certificate of participation provided? Hey, Alistair, Michael, I know you guys are there. Do we provide that? Is that a thing? This is not officially OAA certified, is it? I'm asking my fellow steering committee members if they're there or if they're. We'll have to get back to you on that question. Apologies about that one. Yeah. I did have some questions. You did show, if I could butt in, is it so tempting to want to ask so many questions? You did show the interior's chemical content at one point, but for example, the highly fluorinated materials. I'm wondering, how did that tie in to this? I'm sorry if I missed it.
Yeah, so that's about our material policy. I think that's kind of one of the beginning slides, Lizzie. You could go to slide sorter and pull that up. That's more just another lens that we want our design team to consider, because when you're choosing a material, there's so many different things you have to think about. And we're asking them, as in our building science and sustainability group, we're asking them to also think about material health and embodied carbon. And so for us to put it into Kaleidoscope together is a way that you can toggle between those two decisions and kind of make that value choice as well. It's more of a, to give somebody kind of a signal of, is this product going to typically have something that might be on our Payette's no material list? And if so, can we find a specific product that doesn't have it? That's kind of the thought process between like the red, green, and yellow. Is there's a little bit of information on Kaleidoscope with some info, and we have a whole bunch of stuff on our material policy as well there that gives a lot more information, but it's basically just the 6 classes, those first 3 plus final. And this is our way of tackling the many different ways you can look at material health. And this is just the way that we've started in our office a couple of years ago as well. And there's definitely a lot more different ways to do this. This is just the way that we kind of decided to do it. Perfect.
Thank you for that. I saw that flash in front of my eyes and I was wondering how that all fit in. I see we have another question that came in talking about the adhesives. Just this person's asking about the choice of fasteners instead of adhesives, and just you could comment on that.
Yeah, so the adhesives, I believe Olivia was talking about that with the ceilings and the with the baffles or the veneers. So that is a question that we would actually potentially be adding into with the reuse and slash kind of circularity lens. Right now, we don't have the options to change that, but that is something that we're looking at, including that kind of option with like, can you reuse something and what would be the impact on carbon if you switch that out?
Looks like you got a thumbs up there. Sorry, go ahead.
Great. It's a very complicated topic, so it's going to be a little while till we can get that into Kaleidoscope, but we're working on it currently. So it's good to know that it's of interest.
Absolutely. Well, a lot of the recommendations also are, it's good to see the data. A bit of like the using less is more, is a bit of a something that pops out. There's a term called sufficiency that seems to be getting traction these days. So, and then if I may ask another question about the biogenic carbon, that one popped up a fair amount. And I'm just wondering, and there was also conversations about certain protocols, like ISO protocols, and just wondering if you could maybe elaborate a little bit further about to use or not use biogenic carbon.
Yeah, I'm happy to answer, but Olivia, if you want to take it too.
Sure. Yeah. Melanie, feel free to jump in, but I mean, we take our industry average data is from Tally. So we're using that methodology for calculating the sequestered carbon from biogenic materials. I think there's kind of some wider industry discussion right now as to exactly how biogenic carbon is calculated, kind of depending on like the way things are harvested and forested, and should it be kind of like plant specific. But yeah, I don't know if there's more to add, Melanie.
Yeah, so we do in our the little question mark pop-up, do recommend that you only use the biogenic carbon lens if you are using FSC or other responsibly forested wood. So that's kind of where we're at right now. And otherwise you shouldn't be taking that credit for using biogenic materials. But yeah, as Olivia said, we know right now there's a lot of research about how do we actually account for biogenic carbon? And we've had a lot of these questions. So right now, all we can do is use the data that we have, which was previously vetted through Tally and Gabby and ISO standard, but I feel that might potentially change in the future.
Thank you. Well, if we don't have any other questions, I think it was a very thorough presentation. I mean, you covered a lot of ground and a lot of data, a lot for us to think about. I want to say perhaps we can sign off early. So I see anything else come in the chat? Okay. Well, thank you so much for that. We really appreciate all the work that you're doing, and we hope to see you around again soon from the Carbon Leadership Forum Toronto chapter. We thank you.
Thank you for having us.
Thank you for having us.
Thank you. Bye.
And definitely if you guys have questions, you can email us.
Yeah.
Fantastic. Thank you.
Thanks.